I'm Kevin Richardson, Director of User Experience at Infragistics. My colleague Ken Eisenhuth and I were asked by Keysight Technologies, one of the world's leading electronic measurement companies, to redesign the software that controls their line of atomic force microscopes. Originally created for the scientific community, the application had a very steep learning curve that took years to master. Part of the problem was that the application presented all of the microscope's functionality all of the time to all of the users. In addition, the application was designed around the standard multi-window Microsoft desktop design language, meaning that completing a single task meant having a lot of open windows. As a result, 0% of new users were able to successfully use the application. Experienced users required years of training, and powerful functionality remained hidden in plain sight. Keysight needed to decrease training time, allow experienced users to focus on scientific research rather than learning a new interface, and open up the technology for use outside the traditional academic areas of physics and chemistry. Our design needed to support the workflows of multiple types of users. Physicists and chemists with a long history of using the application, and in some cases helped design the original version, needed to be able to transition seamlessly to our new design. New academic users and technical support staff who were familiar with the purpose of an atomic force microscope but not with the application that controls it also had to be considered. And finally, we were designing for a new group of commercial users who would only be using the device for specific industry-related tasks rather than long-term scientific research. From a strict design perspective, we demonstrated to a very traditional user population the value of a true design process. We were also able to provide alternatives to the poorly designed software they currently use and deliver a useful, usable, and visually striking piece of scientific software. From the perspective of the business, we eliminated the need for novice user training. Novice user success rates went from 0% using the existing application to 100% using the new design. Experienced user training, typically taking place over years, was also substantially reduced, allowing researchers to focus on their work rather than learning a new complex interface. And finally, we were able to incorporate new functionality, making the application more valuable to experienced users while keeping the interface simple and intuitive. We began by conducting in-person contextual inquiries with representatives of the different user groups. Once we understood the mechanics of the application's functionality, the user's workflows and mental models, and the limitations of the physical environment, which included a 32-inch monitor shipped with the microscope, we were able to begin sketching various ways of visually representing solutions. Once we had agreement on the information architecture and the primary interaction models, we created a detailed wireframe prototype that let us explore how users would complete typical tasks sitting at the monitor and from across the room, as well as how our design matched their needs. After 2 rounds of validation, we were able to create the final visual designs and be confident that we had exceeded the expectations not only of our client, but also of their users. And in fact, the best comment we received was from a scientist who told us that this was the sleekest scientific interface he had ever seen.